What's happening, dogs? Mr. Allen here. We're about to write these rational expressions as a single fraction, and we're going to list out any domain restrictions. Now, for this first one here, I got two different denominators. I got to get like denominators. Now, I can either do my domain restrictions at the very end or right away because I can already tell what's going to cause these denominators to equal 0. So I don't forget about it, I'm going to do it right now. I'm going to say x cannot equal, well, -3 for this guy because that would make it 0, and +2 for the other one. Already out of the way, we're good to go. We've got that answer done down there at the bottom. Once I got all my work, it's going to sit right there. It's going to be perfect. All right, now I got to get like denominators, okay? This situation, I just got to multiply the two fractions, numerator and denominator, by each other. So this one's going to get multiplied by x minus 2 over x minus 2, and this one's going to get multiplied by x plus 3 over x plus 3. Okay, beautiful, wonderful, and fantastic. Okay. So when you're multiplying by x minus 2 over x minus 2, you're really just multiplying this fraction by 1, right? It's a creative form of 1, but it's 1 no less. Therefore, it's mathematically equivalent. That's why we're able to do that. It's not just like a, hey, man, I have a math magic trick. It's cool. It's cool. It's street legal, okay? It's street legal. All right. So now I've got 1 times x minus 2. So it's just x minus 2 for this guy plus, and that's 3 times x plus 3. And the reason I don't have the fractions individually right now is because that denominator is going to be x minus 2 times x plus 3. This one's going to be x minus 2 times x plus 3. These two bad boys have like denominators. We can write it all over 1, x minus 2 and x plus 3. Now, be careful here. Common mistake is like, hey, I'll cancel, and the answer is 3. No! There's addition, there's subtraction. You cannot do that right now. Chill, bro. Chill. I got to distribute this 3 in here. So I'm going to have x minus 2 plus 3x plus 9 over that common denominator of x minus 2 times x plus 3. Now, I'm going to combine my like terms. I got x plus 3x is 4x. -2 plus 9 is positive 7 divided by that x minus 2 and that x plus 3. Boom. Now, the last thing we got to check for is, can I factor this numerator, which would allow me to potentially cancel something with my denominator? That's not factorable. This is it with our wonderful domain restrictions that we wrote at the beginning. Remember, we could have done that here. You could still see them here, that it's going to be +2 and -3 for those domain restriction numbers. But doing it at the start is smart too. Either way, as long as you can tell what will make your denominator 0, you can list your domain restrictions. Had something canceled, right? Say that x plus 3 canceled with something in the numerator, you'd still have to list the -3 as a domain restriction because originally it would make it undefined. Okay, so that's important. That's why I usually like to knock this out at the start or after the first step if we have to factor or something like that. I'm getting ahead of myself. Let's do one more. Let's do another one. All right. Let's switch to, how about orange this time? I like that. Okay, so here it's a little bit different, right? I've just got monomials, right? Single terms. Well, let's see here. This guy's a 2. That's a 4. So it looks like I need to multiply this one by, like, say, 2 over 2 right here. That would make this 4x squared. But I also need to multiply this guy by x over x to get my x squared. So that matches. 2 times 2 is 4. That matches. And now I will have a common denominator, right? If you need to, jot down your LCD, your least common denominator, off to the side, right? If you could tell by just looking at it like I just did right here, that's Gucci too, all right? If I ask you what's your least common denominator, it's 4x squared, okay? So here I've got 2 times 3 is 6 minus 1 times x is 1x all over the 4x squared, right? We've got our common denominator. I can just write it as a single fraction now. All right. Can I do any kind of simplifications? Can I factor? Can I do it? No, I can't. But there's one other thing we got to do here. I almost forgot. Domain restrictions. What is x not allowed to equal? Well, if I plugged in 0, my denominator is 0. So in this case, we'll say where x cannot equal 0. Final answer, you do need both parts there if I ask for it. If it doesn't ask for domain restrictions, you probably don't need to do it. You always list them just to be safe, right? But generally speaking, if we want domain restrictions, if we're requiring it as a part of the problem, we're going to list any domain restrictions, all right? There we go. That's dope. That's awesome. See you later.